Okay, stats kids, so we are back. We are just finishing up chapter 3, and we're looking at comparing the mean and median as measures of center. Since those are our two main measures of center that we're going to be using, that also dictates what measure of spread we should be using. And so we're going to talk about what happens with them and why they're useful and which one you want to use in which situation. So when we have what we call the symmetric distributions, your mean and median are going to be roughly the same. They're going to be pretty darn close to each other. And so that's something we really want to pay attention to. When it's symmetric, the mean and median are roughly the same. And so what you really want to use when they're symmetric is you want to stick with the mean, because the mean is so much more powerful. And we'll see that in chapter 2, because we're going to start using the mean a lot in our special type of symmetric distribution. Now, when we have skewed distributions, the mean is going to be pulled towards the tail. So if the tail's to the right, the mean is going to be pulled away from the median towards the right. If the tail's to the left, then the mean is going to be pulled towards the tail to the left, away from the mean. And so because of that, because that skewness that is pulling that mean, the mean is not very good to use if you have a skewed distribution. If you have a symmetric distribution, then you use the mean. So we're going to go ahead and look at some dot plots that we have here. So our first dot plot on the left, this is obviously a tail is to the right, so this is a right skewed distribution. And because it's a right skewed distribution, we need to be able to identify which ones are mean and which ones are median. Now, the one that goes, because it's skewed, that goes towards the tail is going to be our mean. And so our mean, we use this symbol for the mean of a sample. And so this value right here is going to be the mean, because it's the closest one to the tail, and that skewness is pulling the mean towards the tail. Now, over here, that makes this our median. And so when you're kind of looking at the median, we're looking at, do I have even area on both sides? Or even amount of dots on both sides? But that mean is looking at that balancing act. That balancing that has to happen, because now all of a sudden I've got a high amount of dots over here, but I've got this tail that kind of extends way far over here. And so with that balancing act, that tail's pulling that balance point over. And so when we look at our next one, we have a left skewed distribution. And so when we're looking at this, again, our tail is off to the left. And so that makes this our mean, because the one closest to the tail is going to be the mean, which makes this our median. So our symbols for mean is the X bar, the bar on top of it, and then for median is the capital M. And so using that, we're starting to see that when distributions are skewed right, the mean is going to be larger. And we see that right here, that mean is larger than the median. But when it's skewed left, because it's pulling that mean to the left, the mean is going to be smaller. And then when they're symmetric, they should be roughly the same. Not always exactly the same, but roughly the same. So how do you know which one to use? Okay, if your data is symmetric, you're going to use the mean. If your data is skewed, you're going to use median. Now, if you're using the mean, you're going to use your standard deviation as your spread. And if you are using median, you're going to use IQR as your spread. Now, if there's outliers, even if it's symmetric with outliers, you're going to only want to use median. If there are no outliers, then you're going to check for skewness. And if it's not, there's no outliers, there's no skewness, then you can use the mean. So the mean is really, really powerful, but it's only accurate if we have no outliers and no skewness. Okay, so we have a sample problem. The following are 5 number summaries for the number of contacts that a sample of high school students had in their cell phone. Describe what these values are telling you. So the first thing we're going to want to look at is, are there any outliers? So I'm going to go ahead and come grab my calculator. And I'm going to determine if there's any outliers for the number of contacts in the phones. So I'm going to go ahead and start with males. And I'm going to go ahead and use blue for males because I guess it's just stereotypical. So I'm going to go ahead. I'm going to look at those quartiles and I'm going to calculate the IQR. And that IQR is 103. So I'm going to do 1.5 times 103. Which gives me 154.5. And then I take that first quartile and I'm going to subtract it. So my lower bound is going to be 64.5 minus 154.5, which gives me a lower bound of negative 90. So are there any numbers lower than negative 90? No, my lowest value is 27. Okay, so then for my upper bound, I'm going to take this third quartile and I'm going to add the 154.5. So 167.5 plus 154.5 gives me an upper bound of 322. Are there any values higher than that? No, because my max number is 290, so there are no outliers. Now we're going to do the same thing for the girls. So we're going to go ahead and calculate that IQR. So I'm going to do 1.5 times, and then I subtract the 2 to get the IQR, which is 97. Which is 145.5. And then from here, I'm going to calculate the lower bound. So I'm going to take that Q3, or the Q1 83, and I'm going to subtract 145.5. Gives me a lower bound of negative 62.5. And since my lowest value is 22, I have no outliers on that end. So now I'm going to do the upper bound. So I'm going to take the 180. I'm going to add the 145.5. Gives me upper bound of 325.5. And since my highest value is 218, there are no outliers. So now that we know that there's no outliers that are really affecting our mean and median, we can determine the shape of our distribution by comparing our mean and median. So when I'm looking at the males, my mean is 1 in 22.15. My median is 109.5. So based on this, my mean is bigger than my median. And since the mean is bigger than my median, that means that my tail is going to be over here on that right-hand side. So for males, our distribution is right skewed because of that relationship between the mean and the median. So now I'm going to look at females. My mean is 126.71. My median is 129. Now those are kind of close, closer than the males were. So it's going to be skewed, not a huge amount of skew, it's going to be slightly skewed. But my median is bigger than my mean. So that means that instead of being symmetrical, there's a slight skewness. And if we were to look at it, we'd probably say it's close to symmetrical or slightly skewed. But because my tail is pulling that mean, that means this is going to be left skewed. And very slightly, because the difference between these two values is not big, especially when you start looking at IQR. So you could even stay symmetrical because they are approximately, they are not the same, but they're approximately the same. They're really close to each other. And when you start looking at that standard deviation and the IQR, with those being such big numbers, that difference of 2.29 really is not a big difference at all. So you could even get away with symmetrical. And it looks like I wrote that in the wrong spot, so I'm just going to go ahead and grab this right here. Oops. Maybe not. Yeah, just leave that the way it is. I'll just draw an arrow. Okay. Now we're going to go ahead and compare the distributions. So when we're comparing, we're always using comparison terms. So when we're looking at the shapes, males are right skewed. While gives us a little bit of a comparison word. Females are, and then this is kind of a judgment call. You could call it left skewed, or you could say symmetrical. I'm going to put slightly left skewed. Now we would compare, so we compared shapes, then we compare centers. Centers for female are higher. And then I'm going to go ahead and put in parentheses here both mean and median. So centers for females, both mean and median, are higher than males. And then IQRs are pretty similar. One is 103, the other one is 97. But the standard deviation for males is much higher. And then, of course, there's no outliers. So when we're comparing, we're doing a lot of looking at the centers together, looking at the spreads together, looking at the shapes and comparing and looking at those. Saying that over and over. Okay, so now we're going to look at comparing distributions, and we're going to address all the characteristics. So we've got some dot plots, kind of looking at the different ideas that, or different types of problems that you'll see. Again, using comparison phrasings, about the same, much greater than, very similar. So if I look at these two distributions, A and B, let's see, that looks pretty symmetrical. Pretty symmetrical. In fact, they almost look like they're about the same distribution. So we could say they're both similar, or they're both symmetrical. Distribution A is centered right around 90, while distribution B is centered right around 68. So A is centered higher. And I'm going to go ahead and put 90 versus 68. Then B. There's spreads, and I'm going to go ahead and just go with range because that's really quick to address. Their spreads are both probably about 22 or so. And it doesn't look like there's any outliers. Okay, so now we're going to look at the next one. We've got distributions F and G. So let's look at F. Definitely a right skewed distribution, where G is definitely a left skewed distribution. And then we can look at what we would expect to be right about median or mean, or we can look at our modal groups. So definitely a modal group is higher for G than it is for F, yet our median looks like median would probably be right around here, and median would probably be, medians are really similar. And then we could look at means. So depending on what measure of center, since they're skewed, you probably want to look at medians. So medians for our center are pretty similar. And again, I'm just eyeballing these. You could probably go through and calculate it if you want to. But really just kind of getting an idea of about half area for median. And then we could look at IQR range. It looks like the ranges are pretty the same, similar. But because of the skewness, which one would probably have a higher mean? Distribution F, because it has the right skewed, that mean's going to get pulled over here, where this one, because it's left skewed, the mean's going to get pulled over here. So depending on different things. So all of these are things that you can talk about and compare. And when you're doing this, you need to make sure that you're hitting all four parts. You're looking at shape, you're looking at center, you're looking at spread, you're looking for outliers, and you're addressing it. And the one thing you want to be careful of is you don't ever want to put anything that's wrong. It's better to have not enough information than information that's wrong, because the information that's wrong is automatically going to knock you down points. But as long as you're addressing the four major things, you can actually say less and get just as many points as someone who says a ton, as long as it's all still correct and you're addressing your four major points. Okay, comparing box plots. So looking at these box plots where we can look at our shapes. So it looks like we've got really small, small. This is long. This is somewhat long. So this is definitely a right skew. This one has a much bigger spread. You can definitely tell how it's spread out more. This looks a little bigger than this part here, but not by much. But that tail right here, you could definitely tell how long that is. So this is also a right skew. A much stronger skew than the one above. So when we're comparing, we could say they have similar shapes. And I said up here that they're right skew, but when we're just comparing the distribution, I need to say information like that. They have similar shapes. What's that shape? Right skew. And then when I'm comparing the centers, females definitely have a higher median. And I'm going to go ahead and compare those 107 versus 28. Whew. definitely bigger. And then we can look at spread. We can definitely tell that IQR, females have a higher IQR. And then we can look at that. That's about 100 to 75, 78, 77, something like that. I can't really read the numbers very well. I want to say that's 34 and 131, but so right around 100. So 100 versus, I don't know, I'm going to say about 80. Just kind of keep them nice round numbers. So giving approximates. And if you want to round that like that, do the little approximately symbol. So they're saying that, it's close enough. We're getting the idea of it. So we've got shape, we've got center, we've got spread, and males have 2 outliers, while females have none. And that does throw things off because those outliers are high numbers, and it kind of puts them more into that, sorry about that email popping up, but it puts them like a little bit closer more with the females. It kind of goes into that area. But they are outliers. They are extreme values for those males. Okay, next one is comparing stem plots. So this is kind of going back to those shapes for stem plots. For males, we really kind of want to turn the diagram. I'm going to go ahead and take a picture of this. So here's my male. There we go. And then I'm going to take a picture of the female side. So we can get, so I could kind of show you what I'm talking about when I'm saying that you're kind of turning your paper. Okay, so there's our female, there's our male. And so what I want to do is I want to turn this so I'm getting those numbers in kind of like a number line order. So I'm going 15, 15, 16, 17. So it looks like that. So that way I can read that distribution. Now with females, it's kind of weird because not only do I have to turn it so it's a numerical, but now it's upside down. So now somehow I'm going to try and have to flip that. There we go. So now I have it kind of mirrored and it's all kind of funky, but you get the idea because now we're able to see a little bit more of a shape. So I'm only doing this so I can kind of see that shape. So then we can compare. So when I'm comparing males, my males, it's almost a uniform. All my things are between like 2 and 4. There's a little bit of a peak, so we could say it's symmetrical. We could say it's uniform. Either one we could get away with. And on females, we definitely have a peak onto the right and a tail to the left. So this is going to be left skewed. And then we can start comparing center. So we can look modal. I choose not to look modal. I try to look at like median. This would be a good one. So my median's going to be in here. My median's probably going to be right in here. And so our median for males is going to be in the upper 16s. So maybe like 165. And our median for females is going to be right here about the early 160s. So like 162. And again, I'm just estimating. You could actually go in and do that. But I'm giving an estimate. And so if I'm giving an estimate, we want to make sure that we're saying approximately. So we get an idea of whose center is bigger, what's going on there. We're getting some comparisons. And then spread. You can definitely tell. This one only spreads like 4 bin widths. While this one spreads 1, 2, 3, 4, 5, 6, 7, 8. So 8. So there's definitely much bigger spread, with males. And so when we're comparing them, we're looking at this. Males are way more symmetrical and uniform than females, who tend to be left skewed. Males have a higher median than females at about the upper 160s versus the lower 160s. Males are definitely more spread out, and you could do range or you could do an IQR to describe that. Females are way more condensed, less spread. Doesn't really look like there's outliers on either one. There's nothing that seems really extreme. All of these are just different ways to compare. And remember, practice putting and writing. The more you write it out, the better you get at this description. Am I not recording? Did I do that all? I'm not recording? Sorry about that. Scared myself for a little bit. We are recording.